see this going down here, it is live and recording, so it hears you. Right, that's what I was saying, is it's recording now. So. Somebody tell me what a quadratic is. Okay, you would think, but actually, no, I'm sorry. What kind of equations? So you've got linear is a type of equation that can be graphed, and you've got quadratic. What does a quadratic look like if you graph it? Let me ask you that. I hear several of you saying it and several of you doing it. It looks like a parabola. That's exactly right. We're going to say graphing is. All right, so a parabola looks like this, or, ooh, it doesn't look lumpy like that, maybe like that. Y'all remember doing these now? Okay. Tell me some things about a parabola that you know. Okay, it's infinite in all directions. That's exactly right. It goes up forever or it goes down forever. Tell me something else you know about quadratic. It's got a vertex. Where is that vertex? I know what you mean. I know. We call this a vertex, and the vertex is very important for a lot of reasons, and reasons that you'll keep getting to as you get further and further into school, into math. But tell me one thing that's special about the vertex. What happens at the vertex? It meets there. What else happens? It's the middle. It is exactly the middle, which is a good point. So geometrically, what's happening with the parabola through the vertex there? Like what's split in half? Somebody said it. It's symmetric, right? It's exactly the same on both sides. And that line of symmetry goes straight through that vertex, okay? And in fact, we call it the axis of symmetry because it cuts it exactly in half. Y'all okay so far? What else happens at the, and y'all might not remember this, so I might be pushing you a little bit, but what else happens at that vertex? Take your finger on your parabola and start going along the graph. When you hit the vertex, what happens? I'm going back up, so what am I doing? It's the peak. It's changing the direction it's going, right? When you say peak, I'm gonna say minimum or maximum, but it is a peak, and it's changing the direction that it's going. So sometimes we call this a change of direction point, right? Because that's when it stops going down and it starts going up. Calculus is fixing to learn that this actually means it has a value of 0 there in rate of change speak, but no worries, we'll get there soon enough. So you never quit learning about vertices is what I'm getting to here. All right, anything else you know about a parabola or a quadratic? Tell me in terms of the equation. So this is what the graph looks like. What does the equation itself look like? So that's for a line. So you're right for a line. If it's linear, I've got something like it could be mx plus b, it could be ax plus c, it could be all the, or no, that's the same thing. Shut up, Stacey. Ax plus by, right? Or I could have point slope, but this isn't a line, right? It's a quadratic. So what makes a quadratic equation different than a linear equation in terms of the equation itself? You're exactly right. You are exactly right. That squared on the x is what makes it a quadratic. It has some term, we call it a term, right, in the equation. It has a term that has an x squared hook to it. The squared on the x is what classifies it as a quadratic, okay? Notice on the linear, right, that exponent on the x, it never had one, so it was a 1. That's what made that linear. But the quadratic has an exponent of 2. So this equation in standard form, and that's what we're really going to focus on today is standard form. Notice all these different ways I can write the equation of a line. Quadratics are the same. I've got all these different ways that I can write the equation, but today we're going to focus on standard form. So what standard form looks like is ax squared. Now, a is a coefficient, right? It's a number in front. It could be there, maybe it's not there. If it's not there, what's its value? 1, because I'm multiplying, right? Good job. All right, so ax squared plus bx plus c. There's my standard form of a quadratic, and we're going to work with that a lot today. You remember it now? If I'm going too fast, tell me if I need to slow down. Who did we say was last year for math? Miss Nelson? Is that what we said? Oh, Miss Phelps. That's right. That was my algebra 1. That said. Oh, so y'all haven't done this since. Everything's changing next year, by the way. You'll go geometry, algebra 1, algebra 2. Y'all gonna miss out on that. Huh? Freak out. You don't have to. Just a fourth math. You gotta have 4 maths. Your one from the middle school does not count as a math. It counts as a credit, but not a math. Like you have to have 4 math credits here. This is your second. So you'll need 2 more after this. Yeah. That's the way they used to do it. They're changing everything up. We'll see. You'll want to do calculus. You'll want to do calculus. It's fun. Okay. So we're not going to do a whole lot algebraically. I say not a whole lot. We'll do some algebraic work, but today we're focusing on graphs and what it looks like and what makes it look that way. And these are important skills to have, especially as you get ready for that pre-cal and the calculus that'll come after that. All right. So I've got this standard form of quadratic. And we said these coefficients don't necessarily have to be there. If these are missing, and I don't mean the whole term, I just mean the number in front, okay? If it's missing, then it's 1. But if the whole term is missing, like let's say I had y equals 5x squared plus 7. In this case, what is a? 5. What is b? 0. B's always hooked to the x, so you're always looking for the x to find your b, right? So here it's 0, but I just said if it was missing, it was 1. What's the difference? That's right. Here, in this case, the whole term is missing. But if I had something like 5x squared plus x minus 5, now it's 1. Do you see the difference? So here a is 5, but b is 1. I know I'm kind of jumping all over the place, but back to this example, this original, what is c? 7, right? C is always your constant. It's always the number without the variable. These do not even have to be there to still be a quadratic. You can just have that first term and still be a quadratic, and they can be 0. Okay? Over here on this second example, what is C? -5. That's exactly right. Hey, Wyatt. I know the printer messed up. It's going to be all right. Yeah, I'm not asking Miss Horton to redo the lamination. That'll be your Bible in here for a little while. That's going to be your cold memorization sheet, or part of it. All right. Let me give you an equation here. I want you to tell me, is it a quadratic or not, and what A, B, and C are if it is. So let's. Is that a quadratic? Yes, that's a quadratic. How do you know? The x squared is there. All right, what's A? B. Oh, good job. And C. Quadratic or no? Why? There's no x squared. Can we all identify a quadratic now? Okay. I don't want to insult your. This is an algebra 1 standard, but I find that whenever y'all get to me, you don't know it. Are y'all okay? Sure. All right, let's talk about what these variables, these coefficients, this A, this B, and this C, do to my graph. Because once we understand what they do, it'll be a lot easier to actually graph them. And somebody said yesterday, y'all don't know domain and range. So we might have to take a little time to talk about that. Do y'all remember domain and range? We'll probably have to take a little time to talk about it. It's okay. Sorry. All right. I've got this equation in standard form, and these different coefficients do different things to my actual graph. And so I want to talk about that for just a second. The C is probably the easiest one to remember. Any guesses on what that might be? What it might happen on the graph at C? C is always your y-intercept, okay? Always, always, always. Because y-intercepts happen when x is equal to what? Somebody's fixing to say it. 0. That's exactly right. So if I put a 0 in for all the x's, the only thing that would be left is C. So that's why it's the y-intercept, exactly. So the constant on the end is always the y-intercept. What if it's not there? Then it's 0. Then it crosses at the origin, okay? All right, is everybody okay so far? C gives me the y-intercept. We'll practice with these, but just a minute. All right, A tells us the most about the graph. So we need to talk about it for just a second. All right, A. First thing we need to look at is it positive or negative? Okay. Now, if I do this, do you understand that means positive? If A is positive, okay, that tells me that my parabola opens up, meaning it does this. Okay, it's happy, it's positive. All right. But on the other hand, if A is negative, so if I do this, this means negative, right? Less than 0, anything less than 0 is negative. The parabola, golly, I can't talk. The parabola goes down. That's exactly right. So just by looking at the equation, not even graphing anything, not working anything out, I can just look at the equation and I can say, but wait, I know the y-intercept and I know if it goes up or down without doing anything else. Okay, so it tells me a lot about my graph. I'll give you just a second. Some of y'all are still copying. Y'all got it? All right, one more thing that A tells us. I'm going to come up here above it. Write it wherever you want to. If I do these little symbols, what does that mean? What is it? Absolute value. What does absolute value mean? Okay, so if I want to take the absolute value of a number in simple terms, you want to tell your 9-year-old sister how to do it. Drop the negative. Always positive, right? Drop the negative, always positive. That's your easy definition, right? So if I want the absolute value of A, I'm talking about it doesn't matter if it's positive or negative. It only matters the value itself, okay? This is where it gets confusing. If the absolute, no. It's bigger and bigger. Absolute value of A now, not, don't look at negatives. As A gets bigger, well, Logan Freeman, why don't you tell us what happens to the parabola as A gets bigger? As A gets bigger, what happens to the parabola? No. It stretches which way? Stretches vertically, and a vertical stretch means it's getting, we haven't even got to stretches and shrinks yet. So give it to me in layman's terms. It gets skinnier. We'll talk about shrinks and stretches, but we haven't gotten there yet. All right, so as the absolute value of A gets bigger, the graph itself gets really, really skinny. So if I had a really big number in front, now remember negatives don't matter. So something like, I don't know, 15x squared, that's a really skinny graph, okay? Even if it was negative 15x squared, so this one's up, this one's down, but it's still really skinny, okay? Now, 1 is your normal. That's what I'm comparing to. So as I get bigger than 1 or smaller than 1, I'm talking about in compared to this average graph. That's correct. So as the absolute, you're not even in here. As the absolute value of A gets smaller, and again, I'm not talking about smaller negative numbers. I'm talking about smaller, take the absolute value that gets smaller. So I'm looking at decimals and fractions, right? So maybe this is 1/2 x squared. I'm talking about smaller than 1, but the negatives don't matter, or negative 1/2 x squared. What do you think happens to the graph? It gets wider. Ever do that to me? Do not, Logan. Logan. What? You don't know what? What coefficient have I not talked about yet? I saved the best for last. This is a little bit weird. Why is it weird? What does it give us? What do we use to determine? We haven't learned about transformation. B is going to be what we use to find the vertex of the parabola. And to do that, we need a little equation. We first find the x part of the vertex. And to do that, we do opposite B over 2a. Now, notice I said opposite B, but I wrote a negative sign. That's because, what if it starts out negative? Then it's positive. So it's whatever B is the opposite sign, and then I divide it by 2a. Now, I said x equals because really, this is my axis of symmetry. It's not the whole vertex. The whole vertex, remember, it's a point on my graph, right? And a point has an x and a y. So whereas it gives me, I can use it to find half of the vertex or that axis of symmetry in order to find the other half, and we're going to talk about this, I know I'm going kind of fast. In order to find the other half, I have to plug back into my original equation. As y'all should be. If y'all had been focused in calculus this morning, it wouldn't have been near as hard. All right, so this is all well and good in theory, but until we put it into play, it's hard to really remember and understand. So let's do an example. Let's analyze it first. We'll get into the graphing in just a minute. Give me an equation, Logan. Quadratic equation. go plus 11 so it doesn't have a GCF. We're not going to actually graph this one yet. Tell me what you know. Tell me what you know. Based on the coefficients in there and everything else, tell me one thing you know about this graph. Positive 4, what'd you say? Okay, so 4, what is that telling me? 2a, a is 2. X value of what? X is 1 what? What is that telling me? That's the axis of symmetry. Or part of the vertex. Tell me what else you know. Y-intercept of 11, perfect. Tell me what else you know. At least 2 more things, maybe 3. The graph goes up. How do you know the graph goes up? A is positive. I know I'm opening up. I'm a nice, happy, positive graph. Tell me something else. No. Noah will tell us. Tell us, Noah. What do we know about the graph left from the quadratic? Help them out. What do we know about the quadratic here? Based on A, we know it goes up. We know the y-intercept's 11 based on C. We know the axis of symmetry is 1. What else do we know? They don't know that yet. They'll give it to me in another way. It's skinny. It's skinny. Exactly. It's skinny. Good job. And skinny is relative. It's compared to if A was 1 there. Okay. We know it's skinny because 2 is bigger than 1. As that number gets bigger, my graph shrinks in and gets skinnier. Okay. Just to show you, I know that X is 1. How might I find the other half of the vertex? Because for a vertex, I need it to be as a point. How am I going to plug it into what? The equation. So I'm going to take this equation and I'm going to say y equals 2. And everywhere there's an X, what am I plugging in? 1. 2 times 1 squared minus 4 times 1. What's the rest? Should I multiply first or should I exponentiate first? Exponentiate. How do you know to exponentiate first? Tim does. That's exactly right. Order of operations tell me, and I know that that seems very basic, but a lot of kids will do that. I first need to exponentiate, and then I will multiply. So it's actually just 2 minus 4 plus 11, which is, y'all can do this. Tell me what it is. 9. Good job. So my vertex happens at the point 1, 9. You can do all this. You can graph a parabola in standard form. So we're going to practice. I'm not rubbing your back. I already have another part-time job, remember? This job doesn't pay the bills. All right. Let's do an example start to finish this graph. Y'all ready? No. Ready or not? Anna, give me an easy quadratic to graph, an equation. Like, don't do like what Logan was trying to do and make it harder than what it, but just a random equation. Let's make the middle one. Let's make the middle one even so when they divide by 2, they don't get a fraction. You want to see or no? Perfect. Thank you. It's actually factorable too, so that'll be good because it'll cross the x evenly. You did that on purpose, didn't you? All right, here's what we're going to do to graph this. I'm going to run you some steps over here on the side, I think. Macy Kempton. We're all very surprised there. All right, step one. And actually before, not even really a step, the first thing that I would do is I would probably identify, I guess I could put it as step one. Identify A, B, and C. Because sometimes it throws you if they're not there or they are there. What's my dude's name that's asleep here? Get it? Okay, Logan's got it. Logan's got it. That's a good job for you, Logan. All right, so looking at my example, what is my A? 1. What is B? What is C? Before we get into the steps, tell me what you know. Tell me one thing you know. One thing. The parabola is an average width. That's exactly right. And what average width means is from Logan Freeman. Move away from him. What you know about the parabola? Tell me one thing you know. We said it's average, and I was in the process of telling you what average meant. Average means if you start at the vertex and you go up 1 over 1 from the vertex, that's an average width there. -7 is the y-intercept. That's exactly right. Do you know anything else? Average width, -7, it opens up. It opens up because it's positive. That's exactly right. Exactly right. All right, here we go. Step 1, or step 2, I guess now. They will not be in here every day. They were just here because of that senior meeting today. 3 years. All right. First thing we're going to do is we're going to find the vertex. Me too. I feel bad for me. All right. So the question is, how are we going to find the vertex? Okay, but that may or may not be the vertex. We don't know yet. How can we find the vertex? We have a little formula, right? We're going to first find the x, which is going to be opposite b over 2a. So if I come over here to where I'm working this example, I'm going to say that the vertex is x equals opposite b, so -6 over 2 times a. What's that give you? -3. Now, not only is that the x part of my vertex, but it's also the what? Starts with an A, 3 words, it's the axis of symmetry. So what this means is, even though that is the x part of my vertex, it is also my axis of symmetry. So if I know nothing else, I know where the middle of that parabola is right now. Everybody okay? All right. Boy, it's a lot better. All right. I'm not done with the vertex. I know it's somewhere on that line, but I don't know where exactly. How can I find where? Plug it in. Plug it into what? Your original equation. Go back to that original equation. Plug it in. I'm plugging in -3. Be very careful with negatives. So I've got y equals -3, but I'm squaring it. What's going to happen when I square a negative? Yep, positive. All right, plus 6 times -3 minus 7. So I got 9 minus 18 minus 7. What does that give me? -16. So That's what we get whenever I make up examples of. Well, Anna made this one up. And so -3, -16, that is my vertex. Now, it's kind of hard for me to graph all the way down. I'm not going to count down to 16. Yours you'll be able to count down on yours. I'm going to just put a point here, and I'm going to label it -3, -16. That's going to be my vertex. You'll want to probably either have your axis of symmetry drawn through there or label it with a V or something of the sort so that you remember, because we're fixing to do a couple more points, and you remember that that one's your vertex. That's where it's turning. That's your bottom or your top. By the way, will this one have a maximum or a minimum? Why? How do you know? It's negative. Think a little bit differently about the parabola. Why would this one have a minimum? Because it opens up. If it opens up, then it has a lowest point, right? But if it opens down, then it has a highest point. Does that make sense? So if it opens up, it's got a minimum, but if it opens down, it's got a maximum. Okay. All right, so we got this point. Now we need at least 2 more points in order to graph this. And here's where your steps kind of start to get a little bit different. You can do these different ways. So my last, or my third step here is going to be to find an easy point graph. Now, I say that because I might choose a different point than you choose, okay? You might say, okay, well, you know what? My vertex is at -3. Easy to me is going to be right beside -3. I think I'll choose -2, right? And I'll plug that in to find it. That's fine. I'll find that point. For me on this one, and this doesn't work every time, I see a very easy point to graph just looking at this equation. Do you know what it is? Somebody said it. -7, the y-intercept, right? It's already given to me. Why would I do any more work? Okay? So now sometimes you can't use the y-intercept. Sometimes your vertex sits on the y-intercept and you can't use that, and you're going to have to plug something in. Or sometimes your y-intercept is 700 and you can't use it. But for my case here, that's pretty easy to graph. It's pretty close to my vertex. So I think for my easy point, I'm going to use my y-intercept of -7. So I'm going to plot 0, -7. Everybody okay? You can use the y-intercept. Use it. All right. How many points did I tell you needed? 3, right? Because think about the way the parabola works. I've got 2 of them. I need 1 more. Think about what you know about a parabola and look at that graph and tell me what I might could do to find the other. You're exactly right. It's symmetrical. Reflected. Do you remember reflecting in geometry? Make Miss Phelps proud. All I do is I take this point and I count over to the axis of symmetry. How many is that? Count over that many more on the other side. Now I've got 3 points. I call this last step reflect, because I reflected the point, right? Reflect and connect. Don't make it a point. It's not a point. It's a smooth connection there at that vertex. Y'all okay? No, I'm just still holding it. I'm a fidgeter. I don't have the others. No, I'm not so angry. All right, I know that took a long time to run through 1, but that's because I was also teaching you and showing you as we go. Let's do 1 together. Let's see that maybe we can't. Well, I'm gonna hold off on domain and range until tomorrow or the next, or Monday or Tuesday, because I don't want to overwhelm y'all. I've got 6 for y'all to do for homework, but remember what I told you about homework. I mean, it's 10:45. I got 1 more example to do, and then I'm gonna set you loose in your groups to do them. So you'll almost always have time to get through your homework in class, at least probably 75% of it. All right, let's do a negative. Tell me what you know before we start. Y-intercept is 3. There's no B, which means B is what? 0. Yeah. Tell me what else you know. It goes down, which means it has a maximum. Tell me what else you know. Skinny white average. Skinny. It's always opposite of what you think. That's what makes it hard. Okay. The bigger the number, the skinnier the graph. The smaller the number, the wider the graph. That A in front is absolute value. Don't look at the negative. The negative only tells you up or down. That's all it tells you. All right, what's my first step to graph? Identify what? Starts with a V. Okay, well, A, B, and C. A, B, and C. You're right. That's what I put. What's A? -2. What's B? What's B? I need to find my what? Vertex. My vertex. How in the world am I going to find my vertex? I have a little formula, yes? Opposite B over 2A. So it's a find my vertex. What's the opposite of 0? 0. It's just 0, right? It doesn't even matter what's on the bottom because I got a 0 on top. That means whatever this is, it's going to equal 0. It doesn't even matter. Ooh. What does that mean the y part of my vertex is? Look at your equation. 3. Tell me what's happening here. Is that the 0.03? That's the vertex, but what is it also? The y-intercept, right? You see that? We said the y-intercept was 3, but that's also where my vertex sits. Remember, I need 3 points to graph. One of them has to be the vertex. So whenever I need an easy point now, I can't just use the y-intercept anymore. You see why I chose this one now? I can't use that. So now I need another easy point. So I want you to think, what could I use? I need to get a point. This is my axis of symmetry, right? I need a point on one side so that I can reflect it and connect it. I want to pick 2, okay? If I let, I'm going to say easy point. If I pick 2, what's my y value? What is it? What is it? Somebody said it over there. -5. Square the 2, then multiply by -2, and then add 3. So this point is 2, -5. 2, 1, 2, 3, 4, 5. Now, maybe I didn't pick 2. Maybe I picked 1. I tend to stay right beside the vertex. And the reason for that is, think about the way those parabolas go. They go up, once they start going up, like they start going up slowly, but once they start going up, they go up fast, right? I mean, it grows really fast. The further away you get from the vertex, the bigger your number is going to be and the harder it's going to be to work with. So I tend to stay really close to, I probably would have picked 1 or -1, but you're not wrong if you picked anything else. You could have picked 10. It doesn't matter. It's just going to be really hard to graph, but it doesn't matter. All right, so I've got my vertex and I've got an easy point. What do I do now? Because it's all downhill from here. Reflect and connect. Count over 1, 2. Count over that many more. 1, 2. I'm not going to make it a V because it's not a V. It's a smooth connection. Tell me what you think.